servers of a company.
Oh, I see, yeah.
Like a private version of the Wolfram system. And you can incorporate in that system data from the own company. So you can make queries about things that are internal to the company.
Does anybody want a pen? I brought some Wolfram pens. Yeah. Pen. Never know when you might need another pen. Yeah. There you go. Did you want a pen, sir? Hope so. There you go. Uh-huh. This is it. You found the right place. Welcome.
Good enough.
A pen? Or do you have enough pens?
Thank you.
You're welcome.
Thank you.
Uh-huh. Sure.
Well, thank you.
Thank you.
Uh-huh. Need a new pen? Sure. Yeah, I usually don't start these things for a few minutes until after they're scheduled just for that purpose. Yeah, please do. Wonder if we'll be competing with whatever's going on out there tonight. Seems like they have some sort of an event going on. Those are pretty nice to order up a batch of and take on your trips if you ever need them. I usually like to ask before we get started what sort of departments we have here represented today. Chemistry, physics, math, engineering. Lots of engineers, all right. So everybody in engineering probably uses MATLAB, and they're here to learn a little bit about Mathematica because they want to switch over. Is that right? Free samples? You could go online and download a trial right now. Yeah. And just also by another quick show of hands, who's already familiar with Mathematica and uses it? Okay. And who's never used Mathematica before? And who's just used it a little bit? Maybe version 8 or 9? Okay. Wolfram Alpha? Yeah, lots of. We've got some students, some grad researchers in here. Wolfram Alpha, who is familiar with that? Okay. Well, good. I think this is going to be the right talk for everyone then, because we'll talk a little bit about Wolfram Alpha, a little bit about Mathematica.
You have 6:15 there, Central Time.
Yeah.
Is it going to start at 4:15 or a little later?
We're going to give just a couple more minutes for late arrivals. Yeah.
The title I received was in education and research, and I see that it's called teaching and education. Is it the same thing? Or?
It is the same thing. I probably just got my titles a little bit mixed up, but the first half of this presentation will be about teaching, and the second half will focus more on research. Yeah. Ready to kick things off?
We waited 1 minute.
We've got a pretty full house in here, so why don't we just go ahead and get started, and that way we'll have some room for questions at the end as well.
Yes.
Okay.
Well, let me say welcome to everybody. It's good to see a lot of new faces here today. I'm Michael Saunders, the organizer of the ICME seminar series on linear algebra and optimization. The series was organized for many years by Gene Guller, who was my advisor many years earlier before he started the series, although he was always organizing seminars and urging people to come. I'm very glad to welcome Paul Fish today from Wolfram Research. I'm probably not the only person who's used MATLAB forever, but I figure this is my big chance to learn about the competing product. So I should say we have an experiment going that it's the first time we're doing a live streaming video of the seminar. So thank you, Paul, for being a guinea pig. So welcome and thank you.
Thank you for the introduction. I appreciate it. And thank you for your attendance today. So what I'll do first off is pass the sign-in sheet around. If you wouldn't mind putting your email down on this, I would appreciate it. I don't use it for marketing or purposes or anything like that, but I will be able to send you a copy of this Mathematica notebook so that if you want to work through some of these examples on your own time, on your own machine, you can do that with Mathematica or the free CDF player that's downloadable from our website. And this also helps me prove to my bosses that I'm not just goofing off in California all week long, so I do appreciate it if you throw your email down on there for me. And I brought a couple things just to give away at the end of the presentation, so if you're signed in there, we'll use Mathematica and do a random drawing for a couple little giveaways here. But as was stated in the introduction, I'm Paul. I work at Wolfram Research. I support the Mathematica site license here at Stanford and also many of the other Western United States campuses and into Canada as well. So if you have Mathematica here and you need some assistance with something, I'm going to be a good point of contact for you from Wolfram. Stanford does have a unlimited Mathematica site license, so if you need to get access to it, you can go through your IT department here and purchase a copy. I think they sell it at a very reasonable price, just around $100 or so. Will get you a license through this through the Mathematica site license here at Stanford. So just a little bit about what we'll be discussing today. I'll start by talking a little bit about Wolfram Research and the company, as well as getting into some of the Mathematica workflow, what you can sort of expect to see as you're working with Mathematica notebooks. Then we'll spend a little bit of time talking about the teaching applications that you can use Mathematica to support, whether you're sort of getting hands-on with your concept exploration or using Mathematica to pull in some information with our integrated data, or even using Wolfram Alpha and how that pairs with Mathematica. A good portion of this presentation also focuses on research applications. So we'll talk about some specialized functionality and programming. I'll briefly mention Wolfram System Modeler, and then we should have time for some questions and answers at the end. So Wolfram Research was founded in 1987 by Stephen Wolfram. Our flagship product is Mathematica, but we're well known for many other products, things like Finance Platform, System Modeler, Wolfram Alpha. We just released Mathematica Online recently. So we're releasing different products. I would say by far Mathematica is what we're most well known for, and Wolfram Alpha probably comes in as a very close second. Right now, we're in all of the world's top 200 universities. We have exposure in all of the top Fortune 50 companies. We've got about 3 million users worldwide accessing the Wolfram Alpha servers each month, and we have about 1.5 million people accessing the Wolfram Demonstrations project page, which is another really nice resource that I'll review a little bit more with you today as we go on. So people ask me sort of, what's Mathematica all about? What's it best used for? And the answer to that question changes. We're always putting new features into the Mathematica product. But I would say in general, it's really great at creating documents like slideshows, handouts, reports, quizzes, that sort of thing. People like to use it to compute and visualize their workflows. You can use Mathematica to look up any number of the trillions of pieces of curated data that we have available through the software, as well as Mathematica being a really great cross-campus collaboration tool, because it supports work and workflows in many different subject areas. So typically what we'll see is that an undergraduate physics or calculus student might be introduced to Mathematica, and then that student goes on to use Mathematica during their graduate work, and then continues to use Mathematica in a government or private sector. So with that introduction, let's get into what you can kind of expect to see in your Mathematica workflow. We've done several things in recent versions of the software to try and make it a little bit easier for new users to jump in and start to work with the Wolfram language. One of those features is called freeform input, and this gives you the ability to just basically speak with Mathematica in plain English. You can go ahead and hit the equal sign on your keyboard, and then maybe you want to, plot the sine, oops, gotta spell it right, sine of x. So when I go ahead and engage this, it's going to query the Wolfram Alpha servers and then return a result for this plot statement. Now this is how you would go ahead and use the Wolfram language directly within Mathematica to make this plot function. So we can pull that right into Mathematica and then just go ahead and make changes. So freeform input is a really powerful tool that helps new users and even intermediate or advanced users get a quick piece of information or work with the software. Another tool that we have is called the suggestions bar, and in order to illustrate that, I'll just open up a new notebook here, make this just a little bit bigger, and then we'll just type in an expression. This needs to be a lot bigger. So let me just type in something like x squared plus 5x plus 6. So Mathematica will pop up this little suggestions bar, which is just the software's way of suggesting what we might want to do with this calculation next. Maybe we want to put it in a plot. Maybe we want to work with derivatives. Possibly we want to do a lot more than that. You can click on this More button and see some of the other examples of where we could take this next. So maybe I'll just click on Integrate and then Plot. And then we can go ahead and make this just a little bit smaller. And very quickly and easily, you can see that we've now created this plot of this expression, and we've done that pretty quickly without too much of a distraction to our workflow. You know, we can just get right in there and start working with the software. There's a button right here that is called Roll Up Inputs. So you can click this, and then you can see exactly how you would write this out with the Wolfram language within Mathematica if you were just going to go ahead and start typing with that Mathematica syntax. So this is really nice if you're trying to learn how to work with the Wolfram language in Mathematica. Maybe you want to save this bit of coding and come back to it later, share it with colleagues or students. It's just another nice way to be able to interact with the software and start to learn how to program with the Wolfram language at the same time. As you get started, you'll see that Mathematica is governed primarily by 3 simple rules. All functions are capitalized. We use square braces to surround function arguments, and we use curly braces to denote lists and ranges. So here we have that plot statement again, where we have our functions capitalized, we have square braces around our arguments, and we have curly braces around our lists or our ranges. Another tool that we have available to you is called the Input Assistant. So if I just start to type something in Mathematica, it will pull up all of the available functions that start with those letters. So in this case, I started to type PL, and I can see that we have functions available called plot, plot3D, plus, play, and so on. I'll go ahead and click plot, and then we can use this little drop-down menu here to select one of the all of these methods to interact with Mathematica because they're very easy to just sort of jump in there and start working and getting some things done. So finally, I'll point out point and click palettes up here on the menu here where we see palettes. You can choose from things like Basic Math Assistant, Classroom Assistant, Writing Assistant. I'll pull up the Basic Math Assistant and show you what that looks like. So this is basically another way to interact with Mathematica, where we can interact with these buttons that have all the symbols, all the numerology and math functions and stuff that we need to work with. And this is a really great tool if you have an electronic whiteboard in your class, because you can just go ahead and interact right with that up on the screen. A colleague of mine has actually given this presentation just with the Basic Math Assistant. So I know a lot of faculty that enjoy putting together coursework and other things with the help of this assistant. Just to kind of quickly illustrate how this works, we can click on this 2D, we can find our plot function. Once we click on that, we're presented here with that same template to fill in. Now I can find sine of x, where x goes from -5 to 5. So just one more way to illustrate all of the new features in Mathematica that have been released in the last few versions to assist both novice and intermediate users with working with the software and learning it as you go along. As you become more experienced and want to do some new and interesting things with Mathematica, one of the functions that people turn to first is called manipulate. And if you put manipulate around anything in Mathematica, you usually get a pretty interesting result. So let me just illustrate that real quick. I'm going to add a frequency variable here. And then we'll make frequency go from -20 to 20. So when I do that, you can see that it brings up this little slider where we can study how changes in frequency affect this sine wave. You can put this in motion if you want to. And then you can have just this new sort of more visual element to illustrate this concept. Very helpful if you're teaching and maybe a student is having trouble understanding sort of what they're looking at here. Putting these things in motion using manipulate can be very helpful in their learning. And these manipulates can get more and more complex. So here we have one where we not only have a slider to change frequency, we can change amplitude, horizontal shift, vertical shift. Maybe we want to change the wave from sine to tangent or secant and so on. You can use these manipulates and Mathematica to create some very interesting and engaging interactive assignments. So here's a sample lab exercise where we're using that same manipulate. We're asking students to move these sliders around and then answer a series of questions about what they're seeing happening here. And we have a very extensive library of these materials that have already been pre-built. So we have a large user community, and on the Wolfram Demonstrations project page, this is where, as a user, you can develop these models and submit them to us. So this is opening up in the CDF viewer that's embedded in my web software program here, and I can go ahead and change the polynomial fit to this. I can move these points around and get the best fit line. All of these demonstrations have a little blurb here about what you're seeing, who the author was that contributed it. If you want to see what the code looks like for something like this, you can click this preview button, and you can see that there's not a lot of coding to create kind of an interesting and dynamic visual here. You have things like table and plot, and then of course we have it all wrapped in this manipulate function. If you want to download these, you can. You can view them on Mathematica on your computer. You can go ahead and view them through the free CDF player, and then you can sort of explore the code and see what it takes to create these sort of dynamic and interesting examples. So as you start to create more engaging and interactive documents, you're going to find that you can really do it all right in Mathematica, as opposed to having maybe one or two or three different pieces of software that you're using to put these types of activities or quizzes together. Here's a sample handout that was created in Mathematica, and you can see that we're including things like text, a lot of different visual elements, math symbols and other expressions. Everything looks very neat and lined up. And this is all done with just Mathematica. You know, we don't have to have several pieces of software on our computer in order to create these. Here's a quiz that was created in Mathematica, just to give you a flavor, again, of what you can do directly in the software. We have many slideshow templates available, so if you're sharing your work with colleagues or students and you want to put together a quick slideshow, you can go up here to File, New, Slideshow, and then work through these templates. This is just another nice way of being able to have something that looks professional and clean and not have to go through too much trouble trying to set this up yourself. I'm working in the slideshow mode in Mathematica right now, so you can see that I'm making changes to things directly in slideshow mode. I don't have to go to some separate editable document and then go back into a presentation mode later. Much of the point-and-click typesetting, well, all of it really is able. You can go ahead and change those and be able to compute with them right on the fly. So, for example, unlike LaTeX or MathType, you know, I can change this 1 over 2 to the k to 10 to the k, and it's not going to be a problem or crash my machine or anything like that. So if you want to start to use the integrated data within Mathematica, we have a lot of different data sources available. Things related to chemical data or biological data, astronomical data, even like geographical or socioeconomic data. A lot of people get started with data with the free-form queries. So similar to how we hit the equal sign earlier and then typed in that plot the sine of x, we can use that same sort of method to find out maybe what the melting point of caffeine is. So I would hit the equal sign on my keyboard, and then I can return a result of 235.25 Celsius. So this is accessing the Wolfram Alpha servers and collecting this information to pull it directly into Mathematica, so you can get a quick point of data for your calculations or your work. Similarly, we can find out what the molecule of caffeine looks like. Anytime you're curious as to whether or not Mathematica is thinking about something, you can look over here on the right, and this little bar will be highlighted black. So sometimes, in order to initiate these queries, there's a little bit of overhead the first time you do that to find that index. Or I'm possibly just got a little bit of a slow connection, because it doesn't usually take this long. Let's try that one more time here. Oh, there it is. Not sure why we got that time out there, but this is the two-dimensional diagram of the caffeine molecule that is pulled back, and then we can sort of look at that. Maybe we want to look and see what all the different chemicals are in the chemical data set. We can use this argument blank, and then we can take a look and see how many different chemicals are available. Hopefully there's nothing problem with the internet connection here. So you can see there's a lot of different chemicals, over 43,000 different chemicals available in this chemical data set that you could access and get information on, way more than you could probably ever need or want to use. But there's a lot. Maybe we want to find out what all the properties are for each of those chemicals. We can pull properties like codons or ion equivalence, pH, that sort of thing. We can put these ideas together and ask for the molecule plot of caffeine and then get a nice 3D molecule where we can study these bonds and take a closer look at what all this means for our chemistry class. So similarly, maybe we want to look at the literacy fraction of Zimbabwe. We can pull that data into Mathematica. We can put that into a quick bar chart so that we can see what the literacy fraction looks like for all the countries in Africa. And maybe we want to use that manipulate function to make this a little more interactive, where we can look at the literacy fraction between North America, Africa, Asia, and so on. Of course, if you want to work with your own data, you can import data from your computer into Mathematica to do assessment or visualizations on. Here we're just showing how you could take, say, an Excel spreadsheet, maybe look at a quick list plot of that, and then save that information as a document to share with colleagues or with students. We support a lot of different file types in Mathematica, basic formats like table, list, string, multimedia formats, data formats. This is just a small sampling of what's available. Maybe you're curious to know if something like JPEG is supported, so you could just go into this documentation center under the help window, and then we can type in JPEG and get some quick information on whether or not that's supported. Similarly, while I'm here, maybe you've heard about plot, but you don't really know what it's all about. This will show you what plot functions are available in Mathematica, kind of give you some examples and some illustrations of how you might use these. That's very small. And then you can go ahead and make changes right within the documentation center to kind of quickly explore some ideas or concepts. Here's an example that's just showing us importing some files from my computer. So I have this sample lab data. It's an Excel spreadsheet. I'm going to pull it into Mathematica, and then I'm going to create a list plot of that data to visualize it very quickly. Similarly, if you want to pull in some data from a cloud source, you can do that. This example is pulling in a visual from the servers in Champaign, Illinois. It's a zipped file, so it pulls it right into Mathematica. You don't have to unzip it. It unzips it automatically, and usually goes pretty quickly as well. Just to illustrate that you can work with cloud computing if you need to. So I'll go through this next slide a little more quickly, just because I think it's fairly well known that Mathematica does math pretty well. We were built on a foundation of symbolic computation. So if you need to expand a polynomial, you can do that. Maybe you're working with derivatives or integrals. Maybe you're solving quadratic equations. Maybe you're solving differential equations. Here's an example where we have a dampening factor, and this includes a manipulate in it, so we can move this slider to show how changes in the dampening factor affect the curve here. If you're working with numeric computation, Mathematica can work with numeric computation very quickly and very easily. Here we're integrating numerically. Maybe we are solving differential equations numerically. This is the heat equation in one dimension. Here we have Wolfram's nonlinear wave equation. All of these visuals, you can move them around. You can zoom in to specific points. Possibly you're working in algebra. We can create matrices in Mathematica. Here's a matrix example. If you don't like the look of this matrix and you want to convert to a traditional kind of classic mathematics textbook look, you can go up here to Edit, find the Preferences menu. Under Evaluation, you can change these input and output cells from standard to traditional. Now we can create matrices that sort of have that classic matrix look. Maybe we want to use this random integer function to create a matrix, find its determinant, find the dot product of two matrices, find the norm, the inverse, and then we can numerically approximate that last output. Mathematica is pretty helpful for unit computation. This example is just showing how we can use free-form input to solve this calculation that has varying units in it to get 19.7792 meters. I like to try and stump Mathematica by doing something fun here, maybe 3. I don't know, minus 1 parsec in centimeters. So you can see I'm using both numbers, and I'm also writing things out. And the parser in Mathematica, understands this and will return a result for me. You can use this quantity function as well. Maybe you want to add 3 feet to 2 inches. Maybe you want to determine if 3 feet is less than a meter. Convert 3 feet to meters. Simplify joules over seconds to give us watts. And then a lot of this is built directly into the tables that we have here in the visual elements. So you can see that this is grams over centimeter cubed. So you can use Mathematica to compute and visualize essentially anything. We have a lot of different ways for you to visualize your data. We have 2D visualizations like plot, which we've seen several times already today. Parametric plot, vector plot. This is just a small sampling of what's actually available. 3D visualizations. I believe this is the Stanford bunny right here in the list surface plot 3D. You can confirm that though, I don't know. Anybody? Yeah. I was told that at one point, so I don't know. List plot 3D, bar chart, many different data visualizations, and then specialized subject areas and fields. Graph theory, statistics, GIS. Things like wavelets and control systems you used to have to purchase separately as an add-on. Now we just include it in the standard package. We want you to have as many of these tools available to you from the get-go as possible. And one of the reasons we can do this is because we have a very consistent syntax among our commands. So we can take something like plot 3D and then leave all the rest of this the same. Just change plot 3D to contour plot and you can visualize your data differently. Change contour plot to density plot and there's yet a new way to visualize your data. Many of this type of things are built-in interactivity, so we can mouse over these box and whisker charts and see what the max and the median and the min are. As I've illustrated, these graphics are all rotatable. You can zoom into them. If you want to define some of your own user interactivity, you can with maybe a function like tooltip or pop-up window. You can have these mouse overs where we can identify these curves. Here's 3 plus sine of x. Here's 3 plus cosine of x. And a lot of this is automated already. So if you want to have Mathematica take care of your function coloring, you can do that. Branch cuts are handled very nicely in Mathematica. Other software, not so well. Adaptive sampling, we have a nice smooth curve here. And that actually looks a little bit bumpier since I had the resolution blown up on this to 125%. And then just a general presentation. So we have an XYZ axis here on our 3D diagram, just because Mathematica is going to assume that if you're working with these sort of 3-dimensional plots, you're going to want to have some idea of what the scale is. So the basic idea is that if we want to create something like this, you can start with a default plot. You can change the styling, add grid lines, filling, a title, very quickly and easily, and then have a product to share with colleagues or with students. And there's lots of different options too. You can change all manner of styling, lighting, background elements, textures, and so on. So let's switch gears here just a little bit to talk about mobile computing. We have a lot of different apps on our website, things that might be supportive of algebra or calculus, class-specific apps. Even music theory. This is just sort of a sampling of what's available. By far, I would say our most popular app is the Wolfram Alpha app. You can download that on your iPhone or your Android device. And one of the reasons that is so popular is because the Wolfram Alpha is built in to power a lot of series questions. So we call Wolfram Alpha our computational knowledge engine. It's very good at giving you specific pieces of data. For example, maybe you want to know what the properties of iron are. So anyone can go onto the Wolfram Alpha website and find the properties of iron and then be presented with some helpful information. Here we can see what iron looks like on the periodic table of elements, where it's located, maybe an image of something that's representative of iron, and some basic elemental properties. A lot of this data is what we're pulling into Mathematica when we do those free-form queries to ask for data pertaining to the caffeine molecule, for example. Wolfram Alpha is great at comparing two things, so we can compare, say, two college campuses. We don't want to look at Wabash College and Earlham College. We want to look at Stanford versus Berkeley. Actually, I'm going to leave that spelled incorrectly, and you can see that Wolfram Alpha will still understand. Well, I guess not in this case, huh? Most of the time it does. So we can pull up a comparison of the two schools. We can see what their crests look like, where they're located. Maybe you want to get an idea of what enrollment is, so you can see graduation rates. Well done, Stanford. You guys are quite a bit ahead of UC Berkeley there as far as your graduation rate is concerned. This is 2009 reporting, so I don't know where we're at right now in 2014, but maybe you want some tuition statistics, costs of borrowing, annual degrees awarded, and so on. Lots of different information, and Wolfram Alpha is very good at comparing things. Maybe you want to know what if this is a prime number. So, Google's great for getting you information, but you have to find that in the form of links, and then you have to go to those links and look for the data that may or may not exist on those pages. So if we ask Google if this is a prime number, here's the result that we're going to get. If we ask Wolfram Alpha whether or not this is a prime number, we're going to get the answer as to whether or not it's prime. And we can see here that it is not prime. So Wolfram Alpha is a great tool if you're studying in any sort of particular field at Stanford. It doesn't have to be a STEM course or anything like that. And it's available to anyone for free. Now, if you want the Pro version comes with several different features that are not available in the regular version of Wolfram Alpha. Things like step-by-step solutions, the problem generator, the ability to import and export visual and other data into Wolfram Alpha. I'll just quickly illustrate step-by-step solutions here. So I'm logged into my Pro account, and then I can go ahead and click this and see exactly how to determine whether or not this is a prime number based upon either step-by-step, or you can click this button to show all steps. So this is a really nice tool for students to use to brush up on topics. Maybe they don't have the time or attention from a faculty member, and they need to get some practice examples or follow through something that they're not quite understanding from their textbook. This step-by-step solutions is a really excellent tool. And I've talked with a lot of faculty that like to use this just as another teaching element in their classes. Another tool that you have with a Pro account is this Wolfram Problem Generator. So you could go to this website and practice algebra or any sort of math computation. Maybe we wanted to practice expanding some polynomials. Maybe I have absolutely no idea what I'm doing with this. You can get incorrect answers, and then you're presented with a hint here of how you might solve this using the FOIL method. And then once you get this incorrect 3 times, then it will take you to the step-by-step solution. You can also create random data sets in the problem generator. So this is a useful class tool, or if you just want to practice maybe towards the end of summer break to sort of get up to speed on some of this stuff, you can create these random data sets, random problem sets to practice with. So this page shows a lot of other examples regarding the differences between Wolfram Alpha and Wolfram Alpha Pro. I'm not going to go through all these today. I'll show this calculate derivatives one real quick just so you can sort of see one more illustration of the ability for you to enable interactivity when you have a Pro account. If you're using Wolfram Alpha, you can click this, and then you can make these visual elements more interactive right within Wolfram Alpha. Very similar to the manipulates that we were looking at. We're relying on the same technology here. The idea being that with Mathematica, you can support your STEM curricula. We find that departments like physical science, business, mathematics, statistics, engineering, they're going to go to Mathematica to do a lot of the calculations and work that they need to do. Other departments don't necessarily have that need. If you're in nutrition or art and music or linguistics, you're not necessarily going to go to Mathematica for your day-to-day work. However, we do find that they use Wolfram Alpha quite a bit. So that's why it's beneficial to add this particular piece of software to a site license, because particularly with students who are already familiar with Wolfram Alpha and use it every single day, when you get to 100 to 200 people on a campus that are using Wolfram Alpha, it becomes very, very cost effective to just add it to the site license and make it available for all faculty and students, the pro version. So that summarizes the first half of this talk, where we're discussing how we can use Mathematica and Wolfram Alpha in teaching. I think if you haven't used Mathematica before, you should feel comfortable just sort of jumping in there and relying on some of the new tools and features that we've added to make it easier for people to jump in as new users. We'll spend the rest of the talk here just discussing some of the research applications in Mathematica. We've done a lot with Mathematica to try and maximize your CPU use through parallel processing. So you can use Mathematica to automatically parallelize calculations. Some functions like table or other functions have analogs. So in this case, we're looking at table and having a parallel analog called parallel table. This example, we're going to ask Mathematica how long it takes to calculate this. And then the second calculation here is going to be calculated in parallel. So the first time you do this, Mathematica is determining how many cores of processing power I have in my machine, and then it's splitting up the calculation between those cores to speed up the calculation time. I usually run this one a second time just so you can see that there's a little bit of overhead involved the first time that you compute this. You can see that, did it go up? Maybe not. So you can see that running it in parallel, we get a much quicker response. And if you're working on some large project that maybe takes weeks or even months to calculate, this is going to be helpful to you in your calculations. We also have a general function called parallelize, so you can put this in front of anything that you're working with in Mathematica, and if it can be solved in parallel, it will be. So we can just quickly illustrate that. If it can't be solved in parallel, then we'll get this notice just saying that we're going to proceed with the sequential evaluation. So if you're working in Mathematica, try this parallelize function out. A lot of people like to try that out and get their work done a little bit more quickly. We support managed and ad hoc cluster computing, so I know there's a high-performance computing cluster here at Stanford. I believe they have Mathematica installed on it. If they don't, and you're looking to try and get some time with that, please let me know, and we'll make sure that we work with the site administrator here to get Mathematica installed. As you have an unlimited license, so it's very easy for us to make sure that Mathematica is available for that particular use. But you can set up ad hoc clusters as well. Maybe you want to use your GPU's performance power to speed up calculations. You can do that as well. I have an example here that is parallelizing these stream density plot calculations. I won't go through this one today, but when I send this notebook to you, I would encourage you to check it out and see how quickly Mathematica can solve this problem. We have here sort of a table that shows the number of cores and how quickly it can solve it. It looks like the last time I solved this, it took about 2.5 seconds. So if you have an 8-core machine, you can see that there's quite a bit of a speed increase there. Mathematica is a nice choice for programming. It's a multi-paradigm language, so we have a broad range of constructs. It's a great choice for computer science. Here's just a table that's showing all the different ways to express a function in Mathematica. In Mathematica, functions are defined by rules that act on patterns. So if we want to define f of x as equal to x squared, we can do that. And then when we pass the x underscore, it basically stands for any expression. So we can ask Mathematica square whatever we give it. Maybe we say f of 10 to get 100, f of pi to get 9.86902, f of a list, even f of a symbol. We can get that symbol squared. We can also define a function that behaves differently depending on the type of arguments that we pass to it. So maybe we want to have Mathematica compute the sine of 1 over x minus 1 if we pass it an integer. If we give it a real number, then we'll compute pi to 50 degrees numerically. If we give it a string, we'll get this red circle. So we can check this behavior. G of 10, an integer, we should expect to get sine of 1/9. G of 10.1, we'll get pi to 50 digits numerically. And here's G of test to get our red circle. If you can't remember whether or not you've defined a function, sometimes these notebooks can get very, very long. You can use this little question mark operator to determine if you've already defined a function. And of course, we just did. F of x is equal to x squared. Maybe you want to use this asterisk as a wildcard to look at all of the functions and symbols that contain the letters plot. You can do that. I've already talked a little bit about the command completion. Maybe you're creating your own user-defined functions and symbols. So here we're just going to tell Mathematica that my variable example is equal to 10. And now later in our work, as soon as we start to type my variable, we can just go ahead and pull this right into the page. So you can write programs in Mathematica. Here's an example where we're using a simple data analysis program that shows polynomial fits in R-square values. So we're going to call this data fit app. And then we can import some data into our computer, or I'm sorry, into Mathematica. This is a testdata.dat file. We can look at that as a list plot. And then we can apply our data fit app model to give us polynomial fits of up to 8 degrees. Maybe you want to transition that into a parallel program. You can certainly do that. We can change the name to parallel data fit app. We can include parallel table in there. Remember we talked about that parallel analog for table earlier. And then we can compute these in parallel. So when I'm just running it as data fit app, it takes about 9 seconds. And then when I use parallel data fit app, it takes less time, close to 6 seconds. If you're compiling code, Mathematica is a nice choice for that. You can get much faster compiled code execution because of functions like compile. So this example is just showing you how you could take some coding and you can use this function compile to speed up the analysis here. So cfun has compile within it. Ffun, we're not using that quicker parallel processing. So now we can go ahead and ask for timing for this. cfun, which uses the compiled version, is solved in under half a second. Ffun is computed in a little bit longer time, close to 3.5 seconds. So there's some additional information on here about coding and compiling. If you're working a lot with computer science and that sort of thing, this might be a page that you want to take a little bit closer look at. But the idea is that a lot of this is already built into the software. We try and put as much into the Mathematica standard product as possible so that you don't have to get halfway into your research and then call me and say, hey, I need to have the code compiler or something like that in order to complete my work. It's all built into Mathematica, and we're very pleased and happy with that. You can use Mathematica for your statistical analysis. We have a lot of different distributions, computation, functions for computation of properties, parameter estimation and simulation. We can look at some of these examples. Maybe we're working in descriptive statistics. Here is a set of random data that we're generating, and then we can compute the mean of that data, the variance, the standard deviation, interquartile range. And then we can go ahead and generate a new set of data. We'll call that new data. And then we can compare the two to find covariance, correlation. We can import a spreadsheet of data and visualize it. So we're going to import some data into Mathematica here, and then we can fit a model to that data. And then we can visualize the data and the fitted model together. Maybe we want to see what sort of properties we can extract for that data. Anything from ANOVA tables, a coefficient of variation, parameter table. Here in this example, we'll just take a quick look at the ANOVA table for it, and we can be presented with that information very quickly. If you're working a lot in statistics, there's some other examples in here. There's the kind of classic coin tossing example you might expect to see in an introductory statistics class, some simulation and testing as well that I would encourage you to take a closer look at. So Mathematica supports many, many different research applications. Maybe you're working with finance and you want to look up some derivatives or calculate some different financial visualizations. You could do that within Mathematica. Maybe you're working with image processing. Here's an example where we're just adjusting the contrast of this image. A basic example, but illustrates the concept. Maybe you're working with real-time face detection. You know, Mathematica even has a function to assist you with that. Here we have some segmentation where we're segmenting these images and then colorizing the different segments. So I suppose you could use Mathematica in an art or a graphic art class. This is a famous painting called The Ambassadors by Holbein. And it has a hidden skull that's painted into it. And someone created this manipulate to reveal the skull. Kind of a cool example. So maybe you're working with edge detection. Here's another example where we're looking at two corresponding images. So this image of the moon on the left, on the right here, we've rotated that image just slightly clockwise, and then we're asking Mathematica to line up the corresponding points. So here's number 1 over this crater, and then we can see that that's corresponding point, and this image is right here. I'll briefly mention System Modeler. If you're doing a lot of modeling, System Modeler is a great tool that you might want to try out. It's based on the Mathematica standard. You can create hierarchical component-based models with it, and then you can test and run simulations on your models using Mathematica. So the two pieces of software run hand in hand. Ford used it in the development of the drivetrain for the F-350. You can see sort of what this the desktop environment looks like for the system modeler. You can see here where we're running some simulations on this model that we've created. I don't go into a lot of detail in this presentation on System Modeler because really this software could take up a whole 50 minutes of conversation itself. So if you're interested in this product, I know we have a lot of engineering folks in here. We do a lot of webinars for this, so please let me know and we can set up a webinar for you and your colleagues or students where we can talk a little bit more about this product and how it might assist you in the modeling that you're working on. Additionally, there's a couple of examples down here, so if you do want to take a closer look at this, you can click on these. Maybe you want to look at this electric kettle example. These are all just built right onto our website, so anybody can access these at any time. And I like to kind of go through that a little bit more quickly because I find that the conversation on publication and deployment is a little bit more attributable to a larger group. So, you know, we want your work in Mathematica to be able to be shared with your colleagues, with your students, with your friends. So all of our notebooks have cross-platform compatibility. You can deliver your work as a CDF for viewing with the free CDF player that anyone can download online, very akin to Adobe Reader for Adobe Acrobat files. You could save your work as a Mathematica notebook. Maybe you want to save it as a PDF or an HTML or even LaTeX right within the software, as opposed to having to use, you know, several different pieces of software. We have another product called Enterprise Mathematica, which allows you to create CDFs that give the user a much more defined or user-defined experience where they can import and export their own data. I can show a few examples of that. So this is kind of what we're used to seeing today with these manipulates. These are free CDFs where you have these sliders that you move around. Helpful in illustrating and visualizing different pieces of information. Maybe not so helpful if you have some of your own data that you want to take a look at. So with Enterprise Mathematica, you can create enterprise CDF applications. And these would say, for example, allow me to enter in my own equation here. Maybe I want to take a look at this equation. We can update the graph. Then we can still have these sliders. So you get a lot more flexibility with Enterprise CDF. This is another example where we're asking a student maybe to move these points around and graph this, equation. This is just a free CDF that we've been used to seeing tonight, where we're just adjusting these polynomial fits. Helpful for illustration, maybe not so helpful if we have our own data that we want to analyze. This is an enterprise CDF, okay? So we can choose our own file from our computer, and then we can adjust or specify the degree of fit that we want and get a best fit analysis here. And then I just like to show this example because I think it's one of the more interesting ones that's been created to illustrate enterprise Mathematica, where you can create these enterprise CDFs. So we can choose an image from our computer. In this case, we're choosing images of coins. And then we can click this button to process the image. So Mathematica will count up each of these coins, add it up, and then put it into a little histogram down here. And then we can just continue to build on that. So I see enterprise Mathematica used in an academic setting more as a single machine license for a particular faculty member that wants to do generally one of two things or both things. It's very useful if you're building a textbook where you want students to have these extra course materials where they could go into these CDFs and import their own data. It's also very useful in an environment where you maybe have multiple labs across colleges, universities that are sharing the same sort of enterprise CDF. They're collecting the same bits of data, and then they're importing that data into their CDF so that you can have consistent analysis across these different labs. So if this is something that you think is interesting to you, or you might want to look more closely at, please let me know, because it is an expensive product to just buy by itself, but if you get it added to the site license here, you can get some very significant discounts. These last two pages just quickly illustrate what's new with not only Mathematica 9, but Mathematica 10. So Mathematica 10 just came out, I don't know, 4 to 6 weeks ago, not too long. If you haven't used Mathematica 9, you can go directly to this page and see what was introduced with that software. Maybe you're already a whiz at Mathematica and you just want to see what's new in Mathematica 10. This page here at the end will show you kind of what we're most proud of in adding to the Mathematica package. Things like multiple undo, maybe you're working with time series. A lot of these examples take a little bit of time to run, so I don't go through them typically during this presentation, but it is a nice page to illustrate what's new. Maybe you're working with semantic data, possibly you're doing some things with machine learning. There's been some additional functions built into Mathematica to assist with this type of research or work. Geographic computation, so maybe we want to see what the closest ocean is to our current location. Compute the distance, about 5.5 miles. That seems about right, I would say. And some other information here that you can go directly to if you're interested to see what's new in 10. And I think we did an all right job with time. I wanted to leave a little bit of time for questions. I will go ahead and quickly mention that you do have access to Mathematica through the Stanford site license. If you're interested in getting a copy of it, either as faculty or as student, you can contact your IT office. Actually, they have a very nice website. All you need to do is Stanford Mathematica. And you can pull up the page right here to see exactly how to get access. I'm happy to take any questions now, and also if you didn't get a chance to sign the sign-in sheet, now's the time to do it. We'll do the drawing here real quick in just a moment. Yes, sir?
You were using, I'm fairly familiar with Mathematica, but the notebook with the little insert and the tabs, is that a new thing in 10 or 9, or is that the enterprise?
The notebook with the insert and the tabs, I'm not, where were we with that one?
You have like the different examples of the plotting and the sort of display of that information with the tabbable. Is that a sliders? Not sliders, not manipulate, but when you're going through the different sections and you had, like go back to the plotting, the different parametric plot and that stuff, you had like that, right, go back. Like that.
Right here?
Right there, that's clickable.
These are actually not clickable. If you're referring to these, it's just an image that.
And there were some that had tabs at the top. And you were
It wasn't in the preferences, was it?
No.
Okay. Yeah, okay, I think I know what you're thinking of. You're thinking about the data section.
Yeah, back there.
This one?
Yeah, this right there.
Yeah, so these you can click through and then change the images, yeah.
So that's just a standard command, or is that in the enterprise? PDF?
No, this would be available to you right within Mathematica. I've never looked to see how this was created. This question's never come up before, but this is not an enterprise product, so you could create something like this directly within Mathematica, yeah.
So I might use that.
Yeah, it is kind of a nice feature. Were there any other questions? Yeah.
Going back to your question, example like the Stanford Berkeley comparison, can you feed your own data into whatever that construct was?
Yes, you can. So like you can go ahead and collect data maybe in a statistics class. I've had some conversations with people where a teacher will have the students go out and collect data, and then they can import their data into Wolfram Alpha for some quick statistical analysis. You absolutely can, but you have to have the Pro version in order to do that. The Pro version allows you to import and export data and images into Wolfram Alpha.
At the beginning of your talk, you mentioned the Alpha server or something like that.
Uh-huh.
Later on, you talk about making use of your local machine. So where's the division between my going onto your servers and my using the desktop or laptop that I have in front of me?
Right, so Mathematica is a local install, unless you're talking about Mathematica Online, which was just recently released. On your local install for your machine, anytime you hit that equals sign, you're going to be initiating a free-form query. So if I hit equals, it's going to bring up that orange equals box, and then I'm going to be going basically to the Wolfram Alpha. I'm going to be querying the Wolfram Alpha server to bring in that information. Yeah. So if you don't need to use that as a resource, then you would just start to type in Mathematica. Maybe I want to do this plot, so I can go ahead and pull that plot up and then just start to fill this information in and build these examples.
So then, can I ever use your servers to do some humongous calculation, or do you keep users away from it?
Well, I imagine you probably could. It's going to be pretty expensive. I mean, we do have like a Wolfram Alpha appliance that we sell, but that's predominantly used in a commercial setting as opposed to an academic setting. Yeah. But if it's something that you have specific interest or need for, we can definitely talk about that. Were there any other questions? Yeah.
How does Mathematica deal with data that's not really certain? Like you show the melting point of caffeine. That's usually not known exactly what you're doing.
Yeah, so if you're curious about sources, you can go into, I don't think I have Wolfram Alpha open here, so maybe we want to go to, oops, spelled that wrong, didn't I? So if you want to take a look at sources, you can click this button down here, and then you can see where all this data was collected from. Okay. Yeah, we have a group of people that curate all this.
It's hard to believe that they all agree on the same value.
Well, I don't know about that, but it's better than nothing, right? I mean, we're not just putting data in there and not sourcing it, so. Yeah.
We can have more questions, but I especially want to thank Paul for a remarkable presentation about a remarkable system. I didn't want to make you nervous, Paul, but we have with us Professor Jim Plummer, who has just finished being Dean of Engineering for the past 15 years, I think, is it, Jim? So Jim's had a great deal to do with the creation of these wonderful buildings that we're in. And that must have been a major thing, rather like the creation of Mathematica.
Yeah, these are definitely beautiful buildings. Thank you.
I have a couple of questions. Let's hear from the audience. Yes.
So I just wanted to tell you how I use it, because in a way I'm kind of a proxy for the students in my program who don't use it. They were often plotting in Excel,
Yeah.
right?
Yeah.
And so, in comparison, the strength of this is just insane, right? And so, and I was good at math when I was young, but I don't really use it anymore. So the first time I used this, I heard some crank saying that Mars aligning with the moon was going to lift the tides more than ever. And I said, how much gravity does Mars actually have on our tides? And, you know, Jupiter's more. And I figured out numerically the answer. It was so satisfying without knowing anything to just try using your system and actually be able to solve that.
Oh, that's fantastic. So you actually,
They're all lined up,
yeah,
it's simple.
yeah.
I
So
don't care if the mass changes so much at different times in the orbit, but just to estimate things. So what I'm always trying to do is encourage students to think numerically like that, but maybe don't. And they have, like, you know, health data from the Middle East and social science and biology program combined. The thing about this that's extraordinary is that you can actually start thinking numerically without having been completely trained already in that. You know what I mean? You can use this as a much less sophisticated user.
Oh, yes, absolutely.
And so I want to figure, I show them all the demonstrations, I show them how they can modify it. You know, how can you get thinking numerically when you aren't naturally there? So where is the, you know, I did this with Google Maps years ago, and there's these forums where people are actively trying to teach each other how to do that. Where's the community for people that don't really belong in a mathematics or engineering community?
Well, we do have a community of people on the Wolfram page. So if you go to Wolfram Training, this is one resource where you can look at different courses. Many of these are free. You can sort this by specific questions. Maybe you're curious more about system modeler or data science. So you can watch many of these videos. There's also a community of people. What is that page, Raul? The Wolfram community? Yeah. I think that's what it's called, which is relatively new, the Wolfram community page that you can go to. And then the demonstrations project that I showed, that's another very useful community page that kind of spans many different types of field of study. Those would be several resources that I could point you to. This Wolfram community page is a nice page where you can look at a lot of different conversations that are going on. There's a Stack Exchange website that has a very, very active Mathematica community in it. So there is quite a bit of a community for Mathematica products.
Would you recommend as the gateway product Wolfram Alpha Pro? This is like a student that maybe has data about migrations in China or something. If they don't need Mathematica yet,
yeah,
a lot of the suggestions that you showed us weren't in my version when I learned this 2 years ago.
Yeah,
and they're great.
Yeah,
but you know they may not be ready to invest $100 given they're not even sure if they want to use this instead of Excel.
Right, exactly. So a lot of that stuff came up in version 8 of Mathematica, and I think Wolfram Alpha is an excellent choice to sort of get started with some of the Wolfram language, because as you're working in Wolfram Alpha, particularly if you're doing things like with equations and stuff like that, you're going to pick up on some of the language, and then you can jump into Mathematica and transition into Mathematica pretty easily with the tools that I went over in the beginning of the talk, like freeform input and suggestions bar and that sort of thing.
Those are all in Pro, some version of it, or only in Mathematica?
Well, things like freeform input, suggestions bar, that's just in Mathematica. In Wolfram Alpha Pro, you get some benefits like the step-by-step solutions, the problem generator. Those are specific to Pro, yeah. That's why a lot of campuses that I support have started to move to site licensing Wolfram Alpha Pro, because they realize that that it services a larger community and it gives a larger user base to the site license, whereas before it was just people using Mathematica, and that might have been a small group in some cases. Now you can have a product that literally the whole campus could use if they wanted to.
Great.
Yeah.
Yeah, I'm embarrassed to admit this, but I'm often presenting in a PowerPoint environment, And I export things from Mathematica to PowerPoint all the time, and they're static. Is there a way to have dynamic exportation so that your PowerPoint environment can use sliders, for example, to show dynamic effects?
Unfortunately, not to my knowledge at this time. Probably your best bet would be to utilize your PowerPoint slides and then have a separate window open with some of the free CDF viewables. Yeah.
It's just a pain with that.
I understand, yeah.
Well, you mentioned matrices rather briefly. A very important part of MATLAB is sparse matrices. Do they feature in Mathematica?
That's a good question. We can go ahead and quickly look in the demonstration, or I mean the documentation section here. Maybe I'll just try sparse. Am I spelling that right? S-P-A-R? It's been a long week, everybody. Sorry. So when I type in sparse, you can see some of the examples here that we can look for information pertaining to that. Linear algebra, maybe?
Yeah, linear systems.
Okay.
So sparse linear systems would be the question.
You said it on the second one of the first list.
You had a topic.
This one?
Yeah.
Yeah, sparse matrices. So you could go directly here to kind of find out how to work with sparse matrices in Mathematica. Sparse array, it looks like a function that you might want to look at. If you're working a lot in courses, there's also another web page I'll point out called the Wolfram Library. And we've taken a lot of the content that teachers have put together in Mathematica and put it together in one library archive that you can search on for different fields of study. So, you know, it's possible that if the work that you're wanting to do with sparse arrays and that sort of thing might have already been created by somebody, that you could very easily pull that information into a course that you're teaching.
Sparse matrix factorization, so LU factors or QR factors, and they're non-trivial. We need experts to put them in to help solve big systems of equations. Do you know if they already are there?
I don't know if they are. I do know that we have consultants at Wolfram, so you know, not only you, but anybody else in the room, if you have a particular project that you're working on, some question about coding in Mathematica that you just can't quite get over the hump, we can work with some of those technology consultants at Wolfram, and they will work with you directly on your project to kind of get you through some of that stuff or create entire projects with you from the get-go. So do keep that in mind as well. Did the sign-in sheet make it around? Because we can go ahead and do the drawing for a couple of things. That way, if people need to leave, they can, and I'm happy to hang around for any additional questions.
Paul, we're going to mention.
Oh, right, yeah. So if you're doing any work with the Raspberry Pi, that's got a full build of Mathematica 10. Now, you're not going to get a huge amount of processing power with it, but you do have Mathematica 10 in the Raspberry Pi, and I know that's been a very popular choice for not only courses in engineering and other fields, but just for hobbyists and tinkerers. So to keep that in mind. There's a page also that's called the Wolfram. I can't keep all these pages. Technologies. Called. Raul, help me out here, buddy. Connected devices. Yeah. Thanks.
Can you send us these links you've been finding on that email list?
Sure. So if you want to see what sort of devices are out there that can work with the Wolfram language, you can go to this page and see exactly what you could, hook up to Mathematica or work with the Wolfram language to sort of tap into the code or do whatever you need to do on. This is just another resource for our community. So we have a good group here. I'm going to do this drawing real quick. Let's see here. Oh, wrong page. I'll make this as fair as possible, and we'll just do a random integer. So we'll search. We'll ask for one number between. Let's see. Got 28 folks here. All right. Number 20. Unfortunately, we signed the 26 through 50 side, so 5, 4, 3, 2, 1, 0. Long, are you still with us? All right, well, you won the Wolfram Papercraft. This is a little Wolfram Spiky that you can build and display in your research lab or wherever. Enjoy. I also brought a set of Wolfram playing cards, and these are kind of fun because one side of the card will have a mathematical equation on it, and then the other side will tell you how to solve that using Mathematica. So you can learn how to program in Mathematica and work with the Wolfram language while you're playing poker. Number 2. Pierre, you're our lucky winner. I hope you play cards. That's pretty much the contents of the talk. Thank you very much for your attendance. I'm happy to hang around and answer any other questions if there are some. Oh yeah, you're welcome.
That's tremendous.
Thank you. Thanks for having me and helping me set this up. Yeah.
That's a good question